It is far more compelling to define molecular gasoline pedals before delving into the assertion in addition to being the most notable and prominent atom smasher in the world. The Big Hadron Collider LHC, run by CERN, is a 17-meter ring of superconducting magnets. It represents the pinnacle of human achievement. In fact, it is so powerful that it could replicate the exact states of the first moment on Earth. However, could the system designed to unravel the universe versus mysteries contain the key to something genuinely unique? One of the most renowned research institutes in the world, CERN was established in 1954, and has 23 member nations and innumerable researchers. It is a hub for cooperation and innovation. Although the LHC is CERN's main project, it is but one component in a vast network of experiments and gas pedals. Examine a path for subatomic trash and a test of skill, patience, and space itself, rather than for cars or p-protons, are accelerated by the LHC to almost the speed of light, which sends them on a collision path that mirrors the energy of the cosmos. Immediately after the Big Bang, the hits produce temperatures that are far hotter than the sun's core. Numerous magnets direct the protons on their journey, and intricate cooling systems maintain the magnets at temperatures lower than space. The beams at the LHC are designed to collide with the spots of 4 particle detectors for different points around the gas pedal ring CMS Atlas. Each of Alice and LHCb has a distinct role in studying various aspects of particle physics. When combined, they function as enormous cameras that capture images of these collisions. After that, researchers examine the debris to look for indications of. By concentrating on the microcosm, we can gain insights into the universe. But with every solution comes another question, and with every discovery comes another challenge. These include the elusive Higgs boson, also known as the God particle, and other anomalies that may hold secrets about the fundamental components of the universe. In addition to being a scientific tool, the LHC is a demonstration of human curiosity and advancement. It symbolizes our entrepreneurial quest for knowledge and our desire to comprehend the fundamental forces that shape our universe. But as we push the boundaries of what we currently know, we also need to think about the more existential and profound questions that arise. For example, what are the risks of exploring the unknown? Could our quest for knowledge unintentionally unleash powers over which we have no control? Within the hallowed halls of CERN, where the boundaries of human knowledge are continuously pushed, a revelation has emerged that chills even the most pro-scientist. Brian Cox, a former CERN scientist and an authority in particle physics, recently made a statement that both fascinated and unnerved people worldwide. Cox's remarks, with frightening clarity, ran: CERN's Large Hadron Collider is designed to simulate a miniature Big Bang. Yes, you heard correctly, a miniature replica of the event that created our universe. The physicists continue by outlining the implications of this goal, demonstrating the enormous potential for new discoveries at the LHC. This includes the capacity to reveal the Higgs boson's mysteries and imagine having the ability to call the very essence of the universe and wield the power of creation in your hands. This is an alluring but dangerous potential. Dark matter is a mysterious material that makes up a large amount of the cosmos. The tiny Big Bang is a truly actual occurrence that occurs within the LHC, not simply a theoretical concept. The temperatures, pressures, and raw energy all recreate the conditions of the universe's birth. It's like being at the beginning of recorded history and seeing the beginning of life itself. However, with such power comes responsibility, and the question is, what if something goes wrong? In fact, something did go wrong back in 1978, when Russian physicist and not Borsky was working on the U-70 synchrotron at the Institute for High Energy Physics in Penno, Russia, when a malfunction caused his head to inadvertently come into direct line of a proton beam. The beam entered his skull at the back of his head and then exited through his nose with an unperceivable power. Borsky had a terrifying encounter. He saw a flash that was brighter than 1,000 suns, yet he wasn't immediately alarmed. He stayed awake and even went to the center for treatment despite the beam's route, leaving a trail of destruction that included burning tissue and bone. The results were both alarming and astounding. One ear's hearing loss and partial facial paralysis resulted from the beam's targeted tissue damage. Remarkably, Borsky maintained his cognitive capacities and pursued a career in science. This event serves as a reminder of particle accelerators' enormous strength and possible risks. The risk of catastrophic events from a particle smasher like the LHC should not be underestimated. The fundamental fabric of existence being changed. These are legitimate worries expressed by reputable scientists, not the stuff of science fiction. The potential for producing a small black hole is one of the most intriguing and scary issues surrounding the LHC's research. The possibility that the LHC could produce such a phenomenon, even on a small scale, is astounding to both the public and scientists. Could this black hole eventually grow out of control, engulfing the Earth from within? Certain scientists have assured the public that any black hole created would be unstable and vanish very quickly. Black holes are regions of space-time where gravity is so strong that not even light can escape. They are giant vacuum cleaners, devourers of stars and mysterious entities lurking in the shadows of our universe. However, the distant potential has generated discussions, anxieties, and amazement at the power we possess. It's critical to comprehend how the LHC may produce a black hole. It all comes down to the fundamentals of particle accelerators. When protons collide at nearly the speed of light, massive amounts of energy are created that distorts space-time itself. For example, if a trampoline is stretched, taut, and a heavy object is dropped onto it, the material bends, and if the object is heavy enough, it may form a well so deep that anything nearby could be drawn into it. This is comparable to what might occur at the LHC in the field of quantum physics, where the laws of the universe are both amazing and strange. It is hypothesized that additional dimensions could exist within our reality, and if they do, the experiments at the LHC could tap into them to create a gravitational well that forms a tiny black hole. Some renowned scientists have even taken notice of this strange particle dance, most notably the late Stephen Hawking, who forewarned of a future in which the Higgs boson may become unstable when energy levels are really high, a cataclysmic catastrophe known as vacuum decay, which would not only kill Earth, but also perhaps the whole universe. Might result from this instability. In his book on the possibilities for humanity's future, renowned English cosmologist and astrophysicist Sir Martin Rees also voiced concerns about the experiments at CERN. He examined the potential risks of particle smasher experiments, including those at CERN. His words were not only cautious, they were full of existential dread. He looked at a worst-case scenario in which a failed experiment could cause a phase transition that would ripple through space-time, resulting in a catastrophe that would engulf the entire universe. Rees' concerns extended beyond theoretical reflections. While he gave these disastrous alternatives a low likelihood, he maintained that even a remote possibility merits careful consideration, since the stakes are great and the margin for mistake is razor thin. To guarantee the safety of the LHC, the scientists at CERN have performed Simulations examine hypothesis and taken every precaution. In fact, Brian Cox himself underlined the significance of these steps. He informed the public that strict safety procedures are in place, despite the unavoidable worries and inquiries about the LHC's operations, comprehensive evaluations, and protocols to guarantee that the LHC's operations are carried out with the utmost care and attention to detail. Cox's reassured the public that the energies involved are, well, within what the Earth naturally experiences, and that the chances of CERN creating a stable black hole are extremely low. Even if one were created, scientists say it would be so tiny and volatile that it would deplete quickly in an energy explosion, a phenomenon predicted by Stephen Hawking and known as Hawking radiation. While mainstream scientists largely reject this idea, it has captured the imagination of many and become a subject of intrigue, fear, or even fantasy. What lies beyond our universe? Could we unintentionally unleash forces or entities that we don't understand? The idea of opening a door to hell has even been sensationalized in various media, adding fuel to the fire of doubt. But how did this concept originate, and what does it signify for scientific research? The idea of extra dimensions isn't new in physics. String theory, a leading contender for a unified theory of everything, suggests that there may be more than the usual 3 dimensions of space and one of time. These extra dimensions could be compacted, iffied, or hidden from our perception, but they might in theory be accessed or revealed under intense conditions. Now imagine the LHC as a giant key opening doors that have been locked since the beginning of recorded history, when protons collide at energy never before achieved on Earth. They could in principle create ripples or waves that probe these hidden dimensions. If these dimensions exist, the LHC might indeed discover them. However, before we get too excited with wild speckle, it's important to remember that while the LHC is certainly powerful, there's no definitive proof to suggest that it will open a door to another universe, let alone to hell itself. Nevertheless, the allure of the unknown, combined with the mysterious nature of quantum physics, ensures that such ideas will continue to captivate the public imagination. So, should we be concerned about the LHC and its potential risks? It's simple to get caught up in dramatic headlines and worries about a worldwide catastrophe. But the truth is that scientists are well aware of the risks involved, have taken every precaution to guarantee the safety of their experiments, and continue to monitor and test their work with the utmost care. The research's perspective advantages the discoveries of new particles, the advances in our knowledge of the cosmos, and the investigation of dark matter are just astounding. It's a window into the very core of the cosmos, as well as a display of human ingenuity. But like all significant scientific breakthroughs, it has hazards, so we must approach it with a mix of prudence and wonder. The frontier of scientific investigation, where theoretical physics and experimental reality converge, is represented by the Large Hadron Collider. The sheer size of the machine and the energy it produces are inspiring, and every new experiment opens the door to uncharted scientific territory. However, despite strict safety precautions and extensive simulations, the LH still inspires a sense of mystery and fear in some people, despite its unprecedented potential to answer fundamental questions about the universe, including the origins of mass and the nature of dark matter. Even if the majority of scientists are still satisfied that LHC experiments are safe, there are unavoidable doubts. What if there are unanticipated new abnormalities that cast doubt on our knowledge of physics and the rules of the universe? As particle collisions reveal conditions sealed since the Big Bang, the significance of these experiments increases. posing existential questions about the possible repercussions of changing the very fabric of the universe. Nevertheless, the LHC pushes the limits of human knowledge and tests our control over the natural world. Monumental, it has improved our comprehension of the Standard Model, led to the discovery of the Higgs boson, and created avenues for possible innovations that may ultimately influence our technological future. Nevertheless, the pursuit of knowledge continues to be one of humanity's most ambitious endeavors. The LHC's experiments probe physics domains where intuition is no longer applicable, demonstrating that the path of scientific discovery is seldom risk-free.